We have learned the basic architecture of genetic algorithm, and in the basic architecture there are many operations are involved. One operation is creating the initial population, and then convergence testing, and then selection operation, and finally the reproduction operation. Reproduction include crossover, mutation and inversion. Now, so far the first operation, namely how to create initial population, it basically required to learn about the encoding scheme. So, encoding scheme implies how a problem can be encoded, so that the GA architecture can use it and then follow its operation to produce the output result. Today, we will discuss about in this direction the encoding operation. Now, so different operations, again I repeat it, the encoding, the convergence testing, then creating mating pool, fitness evaluation, it is basically part of the selection, and then so far the reproduction is called the operation or crossover, mutation and inversion. So, today we will discuss about encoding and okay, fine, different genetic algorithm we have discussed about a brief about the different genetic algorithm, like say simple genetic algorithm and steady state genetic algorithm, and also messy genetic algorithm. In fact, they are different from the point of view how the different operations can be carried out, and then also there is one important difference between among these is basically what are the different encoding scheme that they can follow. For example, so far the simple genetic algorithm and steady state genetic algorithms are concerned, they follow the constant length encoding, whereas the messy genetic algorithm constant the variable length encoding. That means, anyway, so let us see exactly what are the different encoding schemes are there, then we will be able to understand about the difference between messy genetic algorithm than others. Anyway, so far the different encoding schemes are concerned, we have listed here few important encoding scheme which are most popular here. So, the first is binary encoding, and then real value encoding, order encoding, and then tree encoding. So, all these encoding scheme will be covered one by one. So, first we will start about the binary encoding, and before going to this, if a particular genetic algorithm follow a particular encoding scheme, then according to the encoding scheme that this algorithm follows, it is termed as that GA. For example, if your genetic algorithm follows the binary encoding to create the population, then it is called the binary GA. The real value encoding is another approach. If it is followed, then the GA is called real GA. Order encoding, if it is followed in genetic algorithm, then it is called order GA. Sometimes order GA is also called permuted GA, and then if it is follow tree encoding mechanism, then it is called the tree encoded GA. Now, so encoding scheme, so for the encoding scheme in genetic algorithm is concerned, basically there are two different things involved in genetic algorithm architecture. One is individual and another is population. So, individual basically related to a solution, a possible solution or a prospective solution, and a set of prospective solution, if it is included, then it is called a population. So, population is basically is a set of individuals, and individual is a particular solution, and population usually at any instant, what are the different at any instant of the searching process, searching for the best solution. In fact, at any instant of the searching process, the set of solutions are basically the population at that instant. Now, let us first discuss about, before going to the encoding scheme, the two concepts in order to encode a particular solution. It is called the phenotype and the genotype. Now, as I told you earlier, the genetic algorithm follows the concept of genetics, and in the concept of genetics, the chromosomes play an important role. So, a chromosome is basically is a collection of genes, and a particular genes gives a particular DNA for an individual. So, every individual has its own DNA code, that is the gene combination. Now, the basic structure of all these chromosomes is called the genotype. So, basic structure means, as you know, genotypes is basically different from one problem to another. That means, for your problem you have to decide exactly the genotype. So, what is the genotype? I can give an idea. So, suppose you have to your objective function consists of different variable like x 1, x 2, x 3 and x n. So, that means, we have to find these are the basically input parameters, and we have to optimize one function which is f for given values of these parameters. Now, here x 1, x 2, x 3 and x n are the n number of design parameters. So, it is also called the factors. For example, factor 1 is x 1, factor 2 is x 2 and factor n is x n. Now, if x 1 has a typical value say 0.5, then it is called the gene value for the parameter x 1. Similarly, for every factor there is a gene value, that means the value of this parameter at that instant. So, this combined is called the gene values for the different factors or the different design parameters in the problem. So, at any instant the values of all the factors constitute what is called the phenotype. That means, gene 1 this part, gene 2 is this part and gene 1 this part is constitute the entire what is called the things, it is called the phenotype. So, genotype and phenotype is involved in this way, and so encoding is basically how a factor can be encoded to give some value, that means gene value. So, we will see the different method for the encoding scheme. Okay, fine. So, before going to understand about the binary encoding, so we can understand or we can say that a gene is the GH representation of a unit, that is a single factor, that is a design parameter. The design parameter may have different values. They can be defined in the discrete domain, they can be of continuous or some symbolic values or number, etc. That means, gene value can be anything, and that is according to the requirement of the problem that you are going to solve. In GA, in fact, there is a need to mapping from genotype to phenotype. That means, for each factors or design parameters that is there in the phenotype, how to map to some values of it, that is the genotype. This eventually decides the performance of the algorithm, that means, the efficiency and accuracy of your problem solving. If you design the encoding scheme effectively and properly, then you can get the result at the earliest and also the correct result. Now, we will come to the different encoding techniques. I have already told 4 different techniques: the binary encoding, the real value encoding, and then order encoding or permutate encoding and tree encoding. Now, binary encoding, as the name implies, it follows the gene value in terms of zeros and 1, that means, the binary representation. You know, anything, whether it is a number, it is a real number, it is a symbol or it is a some other representation, can be represented using binary encoding scheme. So, it basically gives a gene value in terms of only 2 bits called zeros and ones. On the other hand, real value encoding scheme is very convenient to understand from a programmer point of view. It is basically straight away exactly what is the value for a particular parameters is to be stored there, that is why real value encoding. So, it is okay if you want to say factor is a name. So, that name can consist of 20 characters, alphanumeric, whatever it is, that you can store like that. Now, ordered GA is a special case of encoding. It requires not to solve all problems, but there are some problems where the sequence of elements matters. So, if it is a problem like this, then we can encode that kind of problem using the order encoding scheme. And tree encoding scheme is a special form of the encoding mechanism, where it is stored in the form of a tree. So, tree is a concept, it is a structure with which we can solve, we can represent many what is called the problem, and we will learn about tree encoding with an example. So, that understand it. Now, I will first start with binary encoding. As I told you, in this encoding scheme, a gene, the collection of genes basically constitute a chromosome. A gene is represented by a string of zeros and 1, is a binary string. Now, if we follow the fixed length of the chromosome, then they are basically SGA or SSGA. On the other hand, if it is a variable length chromosome, then it is called the MESSGA. Now, first let us see what is the length of the chromosome. Now, in this example, if we see the number of zeros and ones altogether is 18th. So, the length of the chromosome is 18th. Now, here for example, another okay. So, this is the length of the chromosome. So, length means this is the length of the chromosome, and this is the solution 1, that means 1 individual, and this is the individual 2. So, 2 chromosomes are represented here. We have named this chromosome as A and B, or individual 1 and individual 2. Now, here, so this chromosome can be like this, we can think about it. So, these are the first 3 bits for one factor, and these are the 5 bits for another factors, and then this is the 4 bits for another factor, and then finally, these are the 9 bits to another factor. So, we can say this is the parameter x 1, x 2, x 3 and x 4. So, likewise, this is another gene for another factors representing this value. So, here we can see the 4 factors or 4 design parameters have been encoded with their binary values. Now, if we say the binary value, so this represents the 4. So, far the x 1 is concerned, and this represents this is basically 3, right, and this is 5 and so on. So, basically the binary equivalent, decimal equivalent of this binary representation it basically. So, it is a 3, 5 and this is also 5, and this is basically 2, 4, 6, 8, 8, 6, 14 to 16 and 17. So, this basically represents 17 and so on. So, these are the different value that has been represented by these combinations. So, whole the things constitute one what is called the chromosomes. So, this is an essential thing in the binary encoding. So, basically each design parameter can be represented by means of some binary string, and as you know, so binary encoding is powerful to represent any value, whether it is integer. Integer can be coded using the decimal to binary conversion formula. Real value also can be, because there is also formulation by which any real number can be converted in the binary one, and then any symbolic representation, any characters also can be converted, a string of characters also can be converted. So, anything can be converted using the binary representation of the gene. So, the binary representation follows in binary encoding, and this is the idea. I just want to give one example, so that you can understand about the application of binary encoding to solve some optimization problem. I will discuss one optimization problem, it is called knapsack problem, and more precisely it is called 0-1 knapsack problem. Why the name 0-1, we will understand about it. Now, in this problem basically there are n items given to you, and each items is specified by its cost and then weight. So, n items, and then n items has their cost and weights known to you, and there is a knapsack, and then total capacity of knapsack is also given to you. Now, here the problem is to take as much as items as possible, but not exceeding the capacity of the knapsack you have to collect it. As an example, suppose a thief entered into a showroom with a knapsack in his, and knapsack his own capacity, and the different cost of the different items are known there, and the thief has to collect the maximum elements from there, so that he can put all the elements into his knapsack, and so that he can also gain maximum, so far the thief is concerned, he can thief the maximum amount from there. So, basically within the limited weight he has to collect the items, and each items having their own cost, and so that he can maximize the cost from there. Now, so regarding these things, this problem can be expressed in the optimization problem statement, which is here. So, basically the idea is that, so this is the objective function maximize is basically here. So, C I, if the ith item is selected, and W I is the cost, and X I is basically how many of that element is selected, or it is selected yes or no. So, X I is basically if it is selected then 1, if it is not selected then 0, and C I and this one. So, this is basically the objective function in this regard, and then constant is that, constant is, so basically X I into W I should be less than equals to W, that is the constant, because if we select one item X I, then weight of these things and summation of all the selected items should be within the maximum limit of the knapsack. So, that is the W. So, these are the problem and the statement of the optimization problem, and having this optimization problem, let us see how we can solve it. Okay. First we will see exactly how it can be solved using a naive approach, and then finally how the same thing can be solved using GA approach, or basically we will decide about encoding scheme. Now, here this pictorially show one simple instance where the different items, for example, item 1, item 2, item 3, 3 items only are there. For this item 1, the weight is 10, 20 and 30 units, and the cost of the item 1 is $60, $100 and $120, and this is the knapsack. This is the knapsack. The capacity of the knapsack is 50. So, we have to take some items selectively from there, so that we can have the maximum this one. Now, as an example, if we select 10 and 20, then obviously within this capacity, but the solution gives the cost is 160, or say, so 20 and 30 it is possible, and then it will give the cost. So, is 100 and 120. So, this is like this. So, the different solutions. Now, what are the different solutions are possible? It is listed here. So, we can select single item at a time, and then 2 item at a time, and then 3 item at a time. However, this is not a feasible solution, because if we include the item 1, item 2 and item 3, the cost may be 10, 20, 30, but it will exceeds the maximum quota, because the maximum weight is 50. So, it is not the feasible solution. Now, what I can understand is that is basically the problem if we solve in a naive approach. So, out of the n item, we have to select all possible subsets of this n item. The number of possible subsets that is there is basically 2 to the power n minus 1. That means, for this problem there are 2 to the power n minus 1 solutions are possible. So, if the n items are given to you. So, out of these 2 to the power n minus 1, there may be one or more solutions are the optimum solution. That means, it will give the maximum the objective values. Now, here as a genetic algorithm, task is to search for this optimum value. Now, how we can decide the encoding scheme? We can decide the encoding scheme like this. If one item is selected, then we can represent. So, there are 3 n items. So, we can decide the n items, and then the length of the chromosome is n. So, it is basically item 1 and item 2, item 3 and so on n item. Now, if an item is selected, then we can place 1, if it is not selected 0. So, it is like this. So, this way the n out of n items, the subset of n items which has been selected for the solution is a 1 chromosome. So, this way you can represent the chromosome. Now, for example, in this case the number of item is 3. So, the chromosome length is 3, and the different chromosome that is possible in this context is shown here. As the n is 3, so the different number of chromosome in this case is basically basically 2 to the power n, all possible permutations we can see. So, this one are the different chromosomes representing the different solution. So, what we can say, this is the one solution, this solution is basically same as this one, this is another solution represent this one, and similarly this is another solution is this one. So, different solutions can be encoded, and this is basically the encoding scheme in this case. This is the knapsack problem. Now, so the encoding scheme for the 0-1 accept problem in general for n items has the length of the chromosome is n. So, it is a binary string of n bits, and this is the structure. So, this is basically a particular instance, that means a particular individual we can say, or a solution, and this solution is called phenotype, and this is the genotype. This means that any ith bit is basically represent the ith parameters. So, here n parameters basically to solve the problem, whether one particular items is to be selected or not is the concern. Now, let us practice this concept with few more example. I want to give one simple example here. So, suppose this is the one optimization problem where objective function is defined here, and this objective function is to minimize x square by 2 plus 125 by x. That means, we have to search the values of x for which this function f x has the minimum value, and suppose the range of the values is in this range, x is greater than or equals to 0 and less than equals to 15, and suppose s is any discrete integer value, that means 0, 1, 2, 3 are the values, not the real values. Now, if this is a problem, so as it contains only one parameter, namely x, so its genotype consists of only x. So, this is the genotype only, very simple, and so far the phenotype is concerned, we have represent one phenotype, it is like this. So, it has the value say 1 and then 4, 8, so 13. So, this basically represent 13 the equivalent value in decimal. So, we have understood it. Now, you can see one thing that you can note it. So, for x within this range 0 to 15, so there are different values is basically 16, and for the 16 any discrete values, integer values representation, we need maximum 4 binary bits, that means 2 to the power 4, this equals to 16. So, in order to represent 16 numbers uniquely, we need the 4 bits or binary string of length 4. Here we have considered however 5, absolutely no problem. In that case only this is the MSB, most significant bit will be 0. So, within this 4 bit we can represent. So, minimum requirement is 4 and we have considered here 5, we can consider of course, but minimum if it is possible then we should go for this. That means, this x can be represented with 4 bit, so far this constant is concerned. Now, as another example, this is another example little bit complex compared to the previous one, and here this is the objective functions to be minimized, and you can note that this objective function is in terms of 2 parameters x and y. So, here design parameters is 2, namely x and y, and this is the type of the objective function we have to write. That means, we have to find the good values of x and y for which this f can give us the minimum value. Now, here again there is a constant, the value of x and y should be chosen in such a way that it will satisfy this inequality, that means, x plus y should be less than equals to 10. Now, without any special thinking, and here also we see the different what is called the range of values that the x and y should be. So, x should be within 1 and 10. So, 10 different values, and y should be minus 10 to 10. So, 21 different values. Now, so here 10 different values we can easily use, I mean for the representation of x the 4 binary bits. however, I have used the 5 binary bits, absolutely no problem. Similarly, for the 21 we can represent the 21 different numbers within the range minus 10 to 10 by another 5 binary bits. So, it is the 5 representation. Now, at any instant, so it basically shows at any instant, this is basically one instant or one individual or one solution. At any instant, the value of this binary bits here is basically 1 and then 4 and 8. So, 13. So, this basically 13th and similarly, this basically 16, 20, this is basically 25. Now, 25 it is okay. So, 1, 2, okay. So, this is not correct anyway. So, this represents some 25 maybe. Okay. So, this represent 20, however, this is not in this range. So, when you will check it, this will be excluded anyway. So, these are the different genotype and then concern is the phenotype is there, we have discussed it. Now, so we have discussed about the different encoding scheme, the binary encoding scheme, and now we will come to the discussion of real value encoding scheme. The real coded GA is most suitable for optimization in a continuous search space, and it basically use the direct representation of the design parameter. Unlike in case of binary encoding scheme, there is a need to convert any value into their binary equivalent, but here no need to represent in a binary. So, it is a straightforward. Now, for an example, if an objective function is consisting with two design parameters, namely x and y, and their values at any instant, say x is 5.28 and y is this one. So, this constitute the one what is a gene combination or phenotype or is a chromosome. So, it chromosome consists of two values, right, one is 5.28 and this one. So, this constitute a solution, that means at any instant the solution is that x equals to 5.28 and y equals to minus 475.36. Now, so the real value encoding scheme is very simple. However, real value encoding also can be in the form of a binary codes. It is a more usual practice basically. This is because the binary encoding scheme is more faster and gives more accurate results. So, that is why many users, many programmer, they prefer the binary encoding scheme, and in 2-3 slides I will quickly give an idea about how the binary encoding can be adapted in the real value encoding scheme. It is basically use some formula. The formula is that first you have to decide to represent a real value. So, how many binary bits is required at least. So, this basically gives a formula. This formula gives that how many binary bits is required to represent a value, and if the value has its range from XL to XU, where XL is the lower range and X is the upper. That means, if a value is lying within the value range XL to XU, then n can be decided by this one. And here one important factor epsilon decides that what is the obtainable accuracy, mean how much accuracy that you want to have it. Now, from this expression epsilon also can be calculated using this formula. Now, so within this thing obtainable accuracy can be calculated, and then based on this obtainable accuracy we can decide n, the number of bits that is required to represent a real value. For example, if epsilon equals to 0.5, then 4.05 and 4.49 all the values will be within this range will be represented by 4. So, it is this one. On the other hand, if it is epsilon equals to say 1, then 4.00 to 4.99 should be represented by 4, like this one. So, depending on the obtainable accuracy, the range or precision will change, and accordingly the number of bits will be decided. Now, here this is the formula that we should follow in order to understand how many bits is required, and with a desirable accuracy it is there. Now, so this can be followed to solve it. As an example, we say suppose x is within this range and n is the 6, that means we decide the number of bits, that is 6, then obtainable accuracy if x is within this range, then it can be calculated 0.25. So, within the range of the values and then n we can decide the obtainable accuracy, and finally, we can use this one to calculate the number of bits. For example, you can easily calculate. So, with 8 bits and if the number is within this range, and what will be the optimal accuracy. Now, for example, say suppose x equals to 34.35 is a representation, then what is its corresponding binary scheme, binary value. Now, let us see how this can be obtained. It can be obtained easily. Now, this is the formula that can be used to understand that if x p is the current value and then x is basically it is a binary representation, how it will be. This is the standard formula that is followed here, and n is the number of bits in this case. Now, for an example, we can understand about say x l equals to 2 and x u equals to 17, that means the lower limit and upper limit of the parameter x, and n is the 4, that means number of bits that is required, and say suppose x b the binary value that is 10, which is basically in the binary representation can be like this 1 0 1 0. So, 0 2 then 4 8. So, it is 10. This is basically the decimal equivalent, this 10 is the decimal equivalent of these binary values. Now, having this one, so what will be the x that can be represented if it represent x p. So, this can be obtained using this formula. So, here this is basically the x l and this is x u minus x l 2 to the power n minus 1 into this is the current value x b. So, it is 12. That means, this x b which is 10 actually it is 12. So far the real value is concerned in the range 2 to the power 17, and this 12 can be represented using binary, it is called 1100 representation. So, here is the idea about that within a particular range x l and x u, and given the obtainable accuracy, we will be able to represent any binary value in the binary encoding scheme. So, with these things we have learned about the binary encoding scheme, and in the next we will learn about the other encoding scheme. Binary encoding scheme and real value encoding scheme is covered, the other encoding scheme will be covered in the next lecture. Thank you.